In this video, we will be doing a GCSE past paper question on 3D trig. So here we have our question. So here is our prism, A, B, C, D, S, P, Q, R. We have a diagram of our prism. And so the base of A, B, C, D is a square of side 14 centimeters. T is a point on BC such that BT to TC is 4 to 3. So we can label that as 4 to 3. The cross section of the prism is in the shape of a trapezium of area 147 centimeters squared. CR is equal to 12 centimeters. And so it asks us to find the size of the angle between the line ST and the base ABCD, and we give our answer to 1 decimal place. So now we have our diagram labeled with all the information we know. So we know that the base, which is our square, or has the side of 14 centimeters, and with our ratio of our side BC that's split by point T, we can find out that the length of BT is 8 centimeters and the length TC is 6 centimeters, because this is 14 split in the ratio of 4 to 3. And we have the angle that we're meant to identify. So the angle between the base and ST. So we have that labeled here as theta. And so by doing this, it allows us to find what information we need to obtain by doing different calculations. So what we're going to have to do is we're going to have to find the length dt, and we're going to find the length ds, and then we have to use trigonometry to find the size of our angle theta. So our question tells us that the cross-sectional area of our prism is 147 centimeters squared, and this is a trapezium. So we have our trapezium colored out here, which is CDSR, and so we know that the area of our trapezium is 147 centimeters squared. So what we can do is we can use the formula to find the area of a trapezium, which is half times, in brackets, A plus B times H, where A and B are the two sides that are parallel to each other, and H is the height. So the two sides that are parallel to each other are DS and CR. We can keep DS as A and CR as B. Our height is DC, which is 14 centimeters. And so what we can do is we can substitute our values in, and we can rearrange the equation to find A. So 147 is equal to half times A plus 12 times 14. So now if we start to rearrange, we get half times 14, which is 7. So 7 times A plus 84 is equal to 147. So we've multiplied 7 into our bracket. Now we subtract 84 from both sides. So get 147 minus 84 is equal to 7A. This gives us 63 is equal to 7A. Now if we divide both sides by 7, we get A is equal to 9. Now we have found the length of DS as 9. So we are given the length of DC as 14 centimeters and the length of CT as 6 centimeters. So we use Pythagoras, and as that states, the square of the hypotenuse is equal to the sum of the square of the other two sides. So dt squared is equal to DC squared plus CT squared. And now we can substitute our values in. So we get DT squared is equal to 14 squared plus 6 squared. So dt is equal to the root of 14 squared plus 6 squared. So dt is equal to 2 root 58. So this should be the answer that your calculator gives you. And now we have the length of dt as 2 root 58 centimeters. So now we are on our final stage of the question where we have to find the angle between ST and our base ABCD. So the angle we have to find, we have labeled theta. And so we have the length of side SD as 9 centimeters. I have the length of DT as 2 root 58 centimeters. And now we can use trigonometry. So you can use SOHCAHTOA. And for this, we have the opposite side and the adjacent side to our angle. We have the values for those, so we can use TOA. So tan theta is equal to opposite over adjacent. And now we can substitute our values in. So we have tan theta is equal to 9 over 2 root 58. Now we can move tan to the other side. So we get theta is equal to tan inverse of 9 over 2 root 58. This gives us the value of theta as 30.5779476. And the question asks us to one decimal place, so we can't forget our decimal places. And so we get 30.6 degrees as the size of the angle between the line ST and the base ABCD. As always, thank you for watching, and make sure you subscribe so you don't miss out on any new content.